This video is on factoring out the GCF, which is the greatest common factor. Factoring is a big part of algebra, and the very first kind of factoring you need to be comfortable with is finding the GCF. Sometimes the GCF is something very simple like a plain old number. Sometimes it's just a plain old variable. It can get more complicated than that. So if you look at 3x plus 9, looking for the GCF, or the greatest common factor, is a matter of looking at both terms and deciding, is there a number that divides evenly into both of these? And there is. 3 will go into both of those. 3 is the GCF. You're going to take the 3 and put it on the outside of the parentheses, and then divide 3 into each of these. And I suggest you go ahead and draw a line and actually put the GCF underneath to make your division step a little bit easier. With this 3x over 3, the 3's cancel, leaving an x. 9 divided by 3 is 3. This is the factored form of 3x plus 9. These are equal to each other. This is factored, this is not. We can check this by going back and multiplying with the distributive property. 3 times x is 3x plus 3 times 3, which is 9. In the first example, the GCF was just a number. In this one, there is no number that is common to both 2 and 9, but notice you have a y in both places. No x in both places. That means y is your GCF. So sometimes a GCF can just be a single variable. I put the y on the outside. I'm going to show my division of the y because it just makes the canceling step easier. In this case, I have a y in the top and a y in the bottom. It just cancels out, leaving behind a 2x. Plus, over here the y's cancel out, leaving behind a 9. And you can check that by going back and doing your distributive property. Sometimes finding the GCF is a little bit more complicated. Something like this. We have got multiple variables and we've got powers, and of course we also have a coefficient. So take this one step at a time. If you look at 4 and 8, the GCF for 4 and 8 is 4. Look at your variable x cubed, x squared. You are looking for the greatest common factor. Now don't be fooled, x cubed is the greatest, but we're looking for what's in common. It's going to have to be the x squared. You can't pick x cubed, it's too big for this part right here. When you look at the y, you have a y to the 4th and a y to the 1st. The greatest thing that's in common is y, or y to the 1st if you want. You look here, you have a z. You don't have a z in this term, so z cannot be considered part of the GCF. It's not in common to everything. Now go back to your variables. There is a simple rule for this. It's going to sound weird. Here we are looking for the greatest common factor, and what we end up choosing is the least power on each common variable. So to find the GCF for variables, choose the least power that occurs for each common variable. So back here I had x cubed, x squared. The reason I chose x squared is because it was the least power. For y to the 4th and y to the 1st, it was the least power. Z to the 5th was not in common to both terms, and that's why it's not part of the GCF. Look at this term and see if we can come up with the GCF of this. For 18 and 24, you might think 2, you might think 3, but you have to come up with the greatest. And the biggest number that goes into 18 and 24 is 6. Look at your variables, x to the 4th, x to the 3rd. For our x's, the least power that's there is x to the 3rd. For the y's, y to the 3rd, y to the 3rd, it's exactly the same for both, so y to the 3rd will be your common factor for the y. And for the z's, z to the 4th, z to the 2nd, the least power that's there on the z is z to the 2nd. So this is your GCF. Now we haven't actually factored it out yet, we've just named the GCF. The next problem is you're going to be asked to actually factor out the GCF. Look at all three terms. The biggest number that goes into all three of them is going to be 4. For x cubed, x squared, x to the 1st, the least power that's there is x to the 1st. So 4x, or 4x to the 1st, is your greatest common factor. I'm going to use that GCF, and I'm going to divide each term by that 4x. It just makes this next step easier. Once you've decided that 4x is your GCF and you write it underneath each term, you want to write it also in front of the parentheses and do your canceling. The 4 cancels with 4, so it's gone. X cubed over x to the first, this is just our quotient exponent law. Keep the base and subtract the exponents. 3 minus 1 is 2. Over here, 8 divided by 4 is 2, and then subtract your exponent and get 2x. Here, 4 goes into 16 4 times, and in this case, the x's are just going to cancel out entirely, and we have minus 4. We can go back and check this by using the distributive property all the way through. 4x times x squared is 4x cubed. 4x times 2x is 8x squared, and 4x times negative 4 is negative 16x, so this checks. Another thing you need to look for is not only that it checks by multiplying back, you want to look inside the parentheses and be sure that there is still not a common factor floating around. There is not. Yes, 2 goes into both of those, but 2 doesn't go into that. X goes into both of those, but x doesn't go into that, which means we have gotten the greatest common factor. So get another one. Between 9, 18, and 3, the GCF is going to be 3. For our x's, x cubed, x squared, x, which is x to the first, take the least power that's there, so it's x. And for the y's, we have a y squared in all 3 places, so y squared is also part of the greatest common factor. We are going to divide by that 3xy squared. Underneath each term, we're also going to write it out here in front of the parentheses. And now we're ready to do our canceling. 9 divided by 3 is going to leave a 3 up here. And then our exponent laws, x cubed over x, y squareds cancel out. So this first term here will be a 3x squared, because if I do the exponent law, 3 minus 1 is 2. Next term, 18 divided by 3 comes out evenly. The y squared still cancel. Do your exponent law with the x squared and the x to the first, and you end up with 6x, or 6x to the first if you'd rather. Here you need to be careful. The 3's cancel out. The x's cancel out. The y squareds cancel out, and you might be tempted to just leave that off. Well, when you're canceling, you are really dividing, and you're saying 3 goes into 3 once, 3 goes into 3 once, and so on with the x and the y squared. So what you really have here is a minus 1 at the end. If you didn't have the minus 1 at the end of the parentheses, when you did this, if you only had that, you don't have the minus 1, you're only going to get a binomial back. You wouldn't get this third term, so we do need this. 20x to the fourth minus 12x cubed plus 9x squared doesn't have multiple variables, but it does have numbers and variables. If we look here at the numbers, between 12 and 20, there's a GCF of 4, but 4 doesn't go into 9. There is no numerical GCF. Now, you may think that means it's 1, which it is. 1 is a common factor to everything. But in this case, we're just looking at the variables. And the GCF for those variables is x to the second power. That's all we have for the GCF is a variable with a power. So I'm going to put x squared underneath each one of those. I'm going to pull the x squared out here and then do my canceling. X to the fourth over x squared, keep the base and subtract, is going to give you a 20x squared. Here the 12 is going to come down. X cubed over x squared, keep the base and subtract, gives you a 12x. Here the x squareds cancel, and you're left with a positive 9. You can go back and check, multiply each of those out, and you will get the original problem. And take a look inside the parentheses. There is no more common factor between all 3 of these terms. So that's the GCF. The GCF leads to some other kind of factoring, which we'll do in some other videos.